A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. I'm doing good. I hope everybody is doing good. I hope that now, when we enter the final laps of geography as a subject, I hope that it is not a subject which worries you significantly. Okay, Asha, you had asked it about it yesterday as well, to approach the atlas, how to approach the atlas. So here, please keep one thing in mind, that atlas and reading of atlas should be explorative in nature. And when I say explorative, you should be able to explore that, because I'm sure many of the areas you yourself are not aware of as of now. So for example, I'll give you a point of reference. Now, in geomorphology, also in climatology, also in oceanography, also, we have come across many different places across the world, from Kola Peninsula in the northern part of Eurasia, to the Rockies, to the Andes, to the Atacama Desert, to the Kalahari Desert, to the desert in Victoria Desert that we have in Western Australia, and the various different water bodies also that you have come across. Now, try to find out where they are, and don't only restrict yourself like what you used to do in a school level kind of an atlas approach, where an individual will give you that demarcate Bay of Fundy, so you will only locate Bay of Fundy and your work is done. When you observe that, observe the area around it as well. Observe how is it that around that entire region you will find a particular prominence of, let's suppose, other geographical features, other geographical fundamentals. Now, when you talk about India, now India is something that you need to know deeply about. So first of all, any particular area that you talk about in, let's suppose, physiography, or start with your own state. First of all, understand what are the boundaries of your own state. Look at the states which boundary your own state. Then look at the location of the other physiographic divisions. For example, the Peninsular Plateau extends from which portion to which portion. Yesterday, we talked about the various different hills and various different mountains. So, their names, from Dhauladhar to Pir Panjal to the Dhang Range to Jammu Hills to Dafla, Miri, Mishmi, Abor. Where is it that Lushai or Mizo Hills are situated? Patkai Bum, where is it situated? So, with that, your approach will increase. And always understand, a couple of questions that you get in prelims with respect to map, these are not random questions that UPSC frames in the spur of the moment. UPSC always frames those questions in keeping in mind the portion of current affairs. So, any area of current affairs or any news in discussion that you come across, and it discusses about any of the region, for example, immediately the effort and the endeavor should be to find out which region is being discussed there. Okay, which particular area is under discussion, find it out where it is situated across that. For example, when we talk about the relevance of electric vehicles, now lithium as a mineral is always in discussion. You will always come across the existence of the lithium triangle that is around Chile, Bolivia, as well as Argentina. So locate these areas, where these areas are. Now, once you develop that explorative approach, automatically you will also take a look at the surrounding regions. But more or less, all the regions that we have covered, for example, the steppes, where is it that the steppes exist in Central Asia? Where is it, for example, that the Campos and the Llanos are situated in South America, the grasslands, the savanna? So just follow that basic approach along with current affairs. It should be more than sufficient. Okay. Is there a need to prepare notes for NCRTs? No, not required. Once, if you are attentive in the class, in the session, and then along with that, if you have kept in mind the additional reading materials, more than sufficient. Okay. So, a very warm good evening to all of you, and welcome to Baiju's Exam Prep. Welcome to another session of Indian Geography, where we shall be developing the concepts from where we left off yesterday. So, yesterday, we left our discussion at the portion of the formation of Peninsular Plateau. Now we discussed what the Peninsular Plateau is. We also had a discussion about the how the Aravalis were created and how Aravalis at one point of time extended even into the reaches of the Delhi Ridge. So all those discussions we have held. Now, today, again, very briefly, I'll tell you about the Peninsular Plateau. And then after that, we shall be moving ahead into the portion of the Ghat sections that we have, the coastal plains and the islands, before moving ahead into the portion of drainage and river systems of India. There, we shall be discussing about the drainage patterns, about the important and the major river systems. There, we shall be covering it briefly, and here the relevance of the river systems, what are the important portions for prelims, that is something we will cover very cursorily. And the portions which are important for mains, for example, why is it that frequent floodings they do happen in the Himalayan rivers? Why is it that interconnectivity and interlinking of rivers is always a prominent agenda for the policymakers for some time now? So the pros and the cons of interlinking of the river, and that is something that we will be discussing in greater amount of detail, where we shall try to develop the basic concepts which will help you in any kind of variation of the types of questions which can be framed from the topic. So here, first of all, we were talking about the Peninsular Plateau. Now, Peninsular Plateau, when we say a plateau, plateau is a flat table land-like structure. It is not only a flat structure, a flat table land-like structure, which means what? Which basically means that in the case of a plateau, you have a structure somewhat like this. So it will have its elevation on the sides, but then on top of it, it will be almost flattish in surface. Now, these are made up of very hard rocks. Very hard rocks. Okay. And these rocks generally, in majority of the cases, they are volcanic in origin. In the case of Peninsular Plateau, all of them are volcanic in origin. In case of Peninsular Plateau, they are volcanic in origin. Okay. Now, the entirety of the Peninsular Plateau was not created at once. Peninsular Plateau was created in various different patches, as we have discussed. So, we have discussed that how you had the formation of the Peninsular Plateau taking place with the help of cratons, right? The building blocks of the land masses and continents. That is what we refer to as cratons. Cratons. So, these are your building blocks of land masses. Very good, Manas. Okay. Now these cratons, they got created first. So you had various different cratons. For example, initially you had the creation of the Chota Nagpur craton here in this area. You had the creation of the Chota Nagpur craton here. Then you had the formation of the Bastar craton. You had the creation of the Karnataka highlands. Then you had, or the Karnataka plateau. Then you had the creation of the Bundelkhand and the Aravalis, which also happened. Right. In fact, it is said that this Chota Nagpur craton, it did have an extension even up to the region of the Meghalaya highlands and the Meghalayan plateau. Right. Now, initially, when these cratons got created, all of these had their volcanic origin associated. So, all of these cratons, so I will write them as well. So, you had the Chota Nagpur craton, then the Bastar Craton, okay, then Karnataka Plateau or the Dharwad Plateau, which is also it is referred to as. So Karnataka Plateau. Then you had the creation of the simultaneously it was happening. You had the Bundelkhand Craton, and you also had the Aravalis. Okay, these were your various different cratons which came into existence. Now they were created billions of years ago. In fact, the evidences indicate that the Chota Nagpur plateau came into existence roughly around 2 billion years back. So that is how old the Chota Nagpur plateau is. Now, over a period of time, these have undergone various different volcanic eruptions. We are talking about billions of years, guys. Please understand the complex life forms which you see in existence across the planet. Many of them they have come into existence only around 300 or 400 million years before present, not even 400 million years, but roughly in the range of 200 to 300 million years ago. That is where the complex life forms got created. So this was created many, many millions of years before that, even billions of years before that. So this had various different volcanic eruptions since that point of time. As a result of that, the height of these plateaus, they kept on increasing. Now, obviously, when a land gets created over a period of time, any land, anywhere, wherever you have a land getting created, now certain places will have a concentrated amount of rainfall in that region, and that will give rise to many of the streams, localized streams, river systems. All of them, they will come into existence. Now all of them, they begin to have a flow. Now what actually happened was, now again I would reiterate, nobody is going to ask you about the detail of the entire formation of the Indian subcontinent, particularly in general studies. That is not going to be asked, and let me give you that with a certain degree of assurance. But this will help you understand the regions of the country which are rich in minerals. I will come to that as well. So here you will observe that you had the various different rivers which started originating from these areas. Now many of these rivers, most of these rivers, you will not find them in present scenario. You will not even find the evidence of these in the present scenario. So how do we get to know that whether a river actually originated from these areas? Based upon the deposits. So they carried out deposits in the region in between them, right? And they formed a kind of a continuity of landmass. That formed the earliest primitive protocontinent of the Indian landmass. Okay. Now, over a period of time, many of these plateaus, they have underwent a series of weathering, degradation, and erosional activities. And as a result, when the top layer gets eroded, weathered, disintegrated, and removed, the bottom layers, which are rich in minerals, they come closer to the surface. That is the reason why you will find that majority of the mineral deposits in our country, majority of all the various different types of minerals, where are they to be found? They are to be found in the older regions of the country. That is in the region of Jharkhand, parts of West Bengal, Chhattisgarh, Odisha, parts of Maharashtra, that is eastern Maharashtra, Telangana, parts of Karnataka, around the region of Rajasthan, around the region of Bundelkhand and the Malwa Plateau, which is in existence. So these are the areas dominant in minerals. But nonetheless, once this primitive or the proto-continent of the Indian landmass was created, that Indian landmass we have seen in the case of the plate tectonics that it began or initiated its movement northwards from the region of the southern hemisphere. It started moving northwards towards the present position and present location. But this movement in itself spanned across tens of millions of years. So it was a very significantly steady movement, even though in comparison to the other plates, it was very fast movement. But still, you can think about it that the movement was around 15 centimeter per year, 20 centimeter per year. So that is not very much. 15, 20 centimeter is something this big. So that is the movement happening in 1 year. So you can imagine that from a visual perception, it is largely stagnant, it is largely stable. Now, as this landmass happened to come over the region of the Reunion Islands, along with the Hawaiian region, these are volcanic hotspots. These are over the areas of mantle plume. So, it is in these areas where you will experience consistent volcanic activities, which happen even today. Even today, these areas they experience consistent volcanic activities. So when you had the Indian landmass coming over to the region of the Reunion Islands, there was a large outburst of basaltic lava. And that basaltic lava, it was something which erupted when you had the western portion of Indian landmass lying over the Reunion Islands. So it is in this area where you had the lava eruption which spread. It spread here as well. Okay, it spread. And basaltic lava means what? Basaltic lava means it can flow easily. It will have a kind of a fluidity associated. So it could flow easily and it spread, right? Now, again, after some time, after a few hundreds of years, after a few thousands of years, another series of eruption would have happened. And thereby, you had these layered form of lava deposits which happened. Layered form of lava deposits which were witnessed. Okay. In between these series of deposits, in many of the areas, you also have water which is trapped, many of the minerals which were trapped. But then overall, all of this was very hard rock, igneous rock. Obviously, when they cool down, you will have igneous rock. And we have also seen that when we have basaltic lava, now its density is high or less as compared to the felsic lava. The basaltic lava's density is higher or lesser? Very good. It is very high. Very good. So the density is high. So that means it will be heavier. So you had very dense and heavy igneous rocks which were created. Now on the sides, you had a kind of a series of step-like formations which was observed, which was experienced. Now this step-like formation, this a kind of a terrace-like formation, this is what is referred to as trepan. And from here, you had the term which was derived, that is traps. Beautiful. So that means most of you have retained what was taught yesterday. Very good. And these traps, they basically give you what is referred to as the Deccan traps. Deccan traps. Okay. That is how the Deccan traps came into existence. And these Deccan traps, now the disintegration, the weathering of the rocks in these Deccan traps, that has led to a creation of black soil. So this is also the area where you will find the predominance or the presence of black soil conditions. Okay. So that is also the region where you will find the presence of black soil. Okay. That is something to be found here. Now, after this, as this landmass got heavier as well, obviously when you have the creation of significant amount of volcanic eruption and significant amount of lava spread, it will become heavier as well, it will become hardened as well. Now, while the landmass was still over the region of Reunion Islands, by that point of time, this entire region had hardened substantially. It became very, very hard and very, very tough. Now, imagine a scenario. I'll take you back to this image. Imagine the scenario when this has become very hard and you have kilometers thick lava deposit which has happened over a period of hundreds and thousands and millions of years. Now, if let's suppose there is a fresh eruption which wants to or which tries to come up from here, do you think that the molten material will be able to come out very easily? Once you have a capping of all these hard and dense igneous rocks, will the volcanic material be able to come out very easily? What do you think? No, it is simple logic. It won't be able to come up so easily. So, there, what happened? Just a moment, guys. Just a brief moment. So, here, as a consequence of that, basically, when you have very hard and dense rocks, they won't be able to come up very easily. They will find a significant amount of resistance. So here, what happened was that these materials they could not come and emerge above the surface. Once they could not emerge or break through the surface, they ended up uplifting the surface nonetheless and solidifying underneath it. So they uplifted this surface in the western portion, and the western portion it got uplifted, and that is the time since when you observe a kind of a slope. General slope of the peninsular plateau is from west to east, because the volcanic materials they could not break through. But if they could not break through, nonetheless, they would simply push the surface. So if the surface was like this, let's assume this is the western part, this is the eastern part. Now here, if they could break through, you would have volcanic eruption. But they could not break through because kilometers thick of lava deposits on top. So they simply pushed the surface, and the surface got lopsided. So since that point of time, the peninsular plateau indicates the general slope. Yes, Bhavi, that is correct. General slope from west to east. Okay. So that is how you had a general slope which has created from west to east. That is the reason why even today you will find that majority of the peninsular rivers they originate in the west, they flow to the east. Even though they might be originating very close to the Arabian Sea, but they do originate in the west and they flow to the east. But then, another factor here, which you have to keep in mind, and that is we do observe, we do know. Now, here, I hope that I can erase the smaller subdivisions which I have created here. But nonetheless, let's suppose I keep a broader marking of this. Now, let's suppose this is the broader subdivision here. Now, if I ask you one question, out of the portion which I shade as 1, let's shade this portion, let's name it as A. And let's shade this portion and let's name this as B. Out of A and B, which of them do you think was created later? much later? Which of them? A or B? Why do you think B was created much later? Please enlighten. Either one. What is that? Which was created earlier? The answer cannot be either one. It was A, which was created much later, because volcanic eruptions have happened there. Whereas in the case of B, the creation happened when you had the creation of these cratons at that point itself. You had the formation of the volcanic landforms at that point of time itself. So B was created much earlier, A was created much later. So if B has been created much later, or B was created much earlier rather, so can we say that across the eastern part, there will be a greater amount of degradation, greater amount of erosion, greater amount of weathering which would have happened? We can have that conclusion, can't we? So that is the reason why you'll find that across the western coast, there is a kind of a continuity of structure of the landmass. But across the eastern coast, there is degraded hills, residual hills, which are remnant and which basically indicate that billions of years ago they were created, but now they are simply the residual of what once existed. Okay, so this gives you the detail of many important parts and the reason of many important parts which the books don't touch upon at all. Any book that you refer, they don't touch upon these details. That is why is it that the plateau has got a general direction from west to east? Why is it that only in the western part you have the presence of black soil? Why not across the eastern part? Why is it that across the eastern part you have many of the breakages which exist? It is not continuous, whereas the western part is still very continuous. Okay, so all that is attributed to the basic formation. But then the landmass which existed at that point of time, the landmass actually did exist significantly in the west as well. But then, when the Indian plate underwent a collision with the Eurasian landmass, when the Indian plate actually collided with the Eurasian landmass, now you had massive objects undergoing collision. And these massive objects undergoing collision meant what? There was significant amount of stress, significant amount of force which was experienced. As a result of that, there was crack which developed across various different parts of the Indian subcontinent. And these cracks, they ended up developing around this area. Right. Around this region, crack developed. Around this area, a crack developed. A fault line developed. And the land simply underwent subsidence. It simply subsided. Why? Because once the crack develops, there is nothing there to hold the land masses in its place anymore. So, what is the consequence of that? It simply underwent or undergoes a kind of subsidence out there. So, that is where the land underwent subsidence. Okay, this is the reason why once the land underwent subsidence in the region of West Bengal and Bangladesh, that is where you will come across a lot of various Indo-Brahm rivers we had talked about yesterday. That is the presence of Indus, Ganga, as well as Brahmaputra. Now, Ganga and Brahmaputra for some time kept on accumulating their water in these areas of the four deep, what form the northern plains. But as soon as the subsidence happened continuously, so the water here found a way to exit and join the Bay of Bengal. And that water, it brought about significant amount of deposits along with itself. That is why in the region of Bangladesh and the region of West Bengal, you have very fertile and very thick alluvial deposits out there. Okay, and that is the reason why Ganga keeps on flowing to the east continuously takes a sudden southward bend to the east of the Raj Mahal hills. And the gap which is created here, this is also what is referred to as the Raj Mahal Garo gap. Raj Mahal Garo gap, or what is also referred to as Malda gap. Okay. Whereas in the areas to the west, that is where also subsidence happened. Now, because of the subsidence which happened, you earlier had a situation where the coastline was, or the plateau was somewhat like this, with a, or if I can be a bit more generous with the slope. So, this was the kind of land. Now, once the crack got created, you had a crack like this. Okay. And this crack which got created meant the portion here simply underwent subsidence. And this portion which underwent subsidence, that creates the very wide continental shelf across the western coastline. And that is the reason why the western ghats, they appear as steep wall like features. Almost, they are not hills or mountains, they are escarpments. Escarpments are what, if you recall the fourth module, escarpments are basically where you have, due to creation of a fault, there is a subsidence of one portion, so that is escarpment. Okay, so that is what you experience there, and that is how eventually you had the creation of this present modern day landmass that we experience. And here also you had various different seismic activities, earthquake activities, which kept on frequenting this area around Gujarat coastline. Why? Because Gujarat is lying on the plate boundary of three important plates. Which are they? We have talked about it. Which are the three plates whose boundary lies at Gujarat? Very good. Beautiful, guys. Indian plate, Eurasian plate, and the Arabian plate. All these three plates, they have their boundary at the region of Gujarat. So any movement across any of the plates instigates a kind of an upliftment of landmass in certain cases, and sudden subsidence and submergence of landmass. It is expected to be the reason why you have certain areas of Gujarat which has emerged above water over a period of time, and many areas which have gone underwater over a period of thousands of years. Okay, so now I hope you understand. Yes, Bhavi, that is supposed to be the suspected reason, the earthquakes. Okay, so now I hope you understand the details of the Peninsula Plateau. Now, the extent of Peninsular Plateau, if you talk about, so basically the northward extent of the Peninsular Plateau is as north as the Delhi Ridge, which is considered to be the extension of Aravalis. Then the Raj Mahal Hills in the east. Raj Mahal Hills, we have seen where the Raj Mahal Hills are. Here you have the presence of the Raj Mahal Hills, right? The northeastern extent of the Chota Nagpur Plateau, that is your Raj Mahal Hill. It is beyond the Raj Mahal Hill where you have the presence of the Raj Mahal Garo Gap or the Malda Gap. That is where River Ganga takes a sudden southward turn. Okay, then Gir Range in the west, Cardamom Hills to the south, Shillong and Karbi Anglong Plateau, which are separated from the rest of the Peninsula Plateau with the help of the Malda Gap. They are also considered to be an extension of Peninsula Plateau. They are separated from rest of the plateau by the Malda Gap. Okay, so now you understand the soil formation, the type of soil in the Peninsular Plateau. So, Peninsular Plateau, wherever you have the older rocks, the older cratonic areas, there you will find that the soil created is a sum product of the disintegration of the igneous and metamorphic rock, that is red and yellow in color. This is the area where you will find black soil. This is the area where you will find alluvial soil. You also know the shape. You also know the reason why the rivers move from west to east. And once the rivers will move from west to east, there will be greater amount of deposit in the east. You also know the reason why the eastern ghats is discontinuous, whereas the western ghats is continuous. And you also know the reason why, despite of having a very steep land feature across the western coastline, we have a very wide continental shelf, but despite of having a very gentle gradient across the eastern coastline, we have a narrow continental shelf. So the Indian continental shelf, or the continental shelf across the Indian subcontinent, is much wider across the west as compared to the east. Okay, just recall this, and your ability to interconnect this will help you in the portion of human and economic geography as well. Alluvial soil is more nutrient rich as compared to black soil. Now, then the Peninsular Plateau can be divided into the various subdivisions. You have the Deccan. The Deccan is the southward portion where you have the presence of the Deccan Traps. You have the presence of the Karnataka Plateau. That is very much a part of the Deccan. Central Highlands includes the areas of Vindhyas, Satpura. Okay, both of these are the creation of Horst and Graben faults, which we have seen earlier again in module 4. So the Central Highlands are created because of that. There you also have the some portions of the Malwa Plateau to the north, and then the region of the Bundelkhand, the central uplands that is present in that area. Then the northeastern plateau, that is your Karbi Anglong and Shillong Plateau. I'll give you the location of this as well, but I want you to be able to locate it on the map on your own. So I will give you the broader location of this. So here you have the Chota Nagpur Plateau. This is your Chota Nagpur Plateau here. This is where you have the presence of the Rajmahal Hills. Okay. Then here you have the Bastar Plateau. Then here you have the presence of the Karnataka Plateau. Karnataka Plateau. Here you will have the Vindhyas significantly, and also the Satpura. In between the Vindhyas and Satpura, there's a rift valley. Which river moves through that rift valley? Narmada. Very good. Then here you will have the Malwa Plateau. Again, a region which is rich in black soil. Okay, this is also a region which is dominant in black soil. Then you have the Bundelkhand Plateau here, which is very, very old. Here you will find the Aravalis extending up till the Delhi Ridge, Delhi Haridwar Ridge axis that you have. Here you have what is referred to as the Madhya Bharat Pathar, or the central uplands. Okay. Here you have the small Telangana Plateau. Here you have the Shillong Karbi Anglong Plateau. And then in the rest of the portion here, you will have the Deccan Traps. This is where you will have the black soil condition. Okay, here you will also find the remnant of the various different uh, kind of apirogenic movements which have happened long back. You have the Kemur Hills, etc., the Maikal, Gavilgad ranges, all of them you will find in between. Okay, so today I want you to open up the map, the physiographic division or the physical map of India. Do locate these various areas, find out where these areas are. That is it. That is the basic work I want you to do. Okay, right? And yes, Baghelkhand Plateau Bhavi extends in this area. This is where you have the Baghelkhand. Okay, and Shama, what kind of Indian and world map should be drawn in answer writing? The absolute rough map, absolute as rough as possible, unless and until you are drawing India like this, right? Please don't draw India like this. I have seen few copies where you have drawn India like this. Please don't draw it. So here you can have a very basic rough. And when I say rough, just remember something, that the western coast is almost linear, the eastern coast is bulged slightly around the region of Coromandel, and then in Andhra region around Vishakhapatnam it goes straight, and then again you have a kind of a bulge here. Then after that, here you have the region of the Gujarat coastline. Just draw this basic, okay? And then after that, you don't need to particularly depict the Indian map itself, but also the subcontinent. If you draw, more than sufficient. Yes, Rajmahal Hills is in the region of Jharkhand. Some part of it lies in the portion of West Bengal. Okay, Rewa Plateau is present in the region of Madhya Pradesh, and that is the area which is extending around the region of Vindhyas itself. Okay, right? Yes, it is not tough. If you are drawing it like this, it is not tough. Remember few of the basics. See, this is the face that you won't forget ever. Then the western coast is significantly straight. Eastern coast slightly bulged around here. Then go bulged around where? Around the region of Rameshwaram. And then go straight up to the region around Vishakhapatnam. And then there is a kind of a bulge around the Odisha coastline. Okay. And I have problem in understanding how the western disturbances bring rainfall till the northwestern Indian when there. So none of these Utkarsh, none of these Zagros, Hindu Kush, or Suleiman ranges, they are not significantly high enough to create a kind of an orographic barrier for them. So that is why they come all the way to the region of the Himalayas, and they don't travel any further, and they are basically directed by the Himalayas. So the western disturbance, the low pressure travels across the foothills because the Himalayas then provide them with a kind of a direction. Okay. Why cracks develop? Because of the impact of the force which was experienced when the Indian and the Eurasian plate underwent collision. Whenever two large objects they undergo collision, there's a lot of force produced, and due to that impact, you had development of cracks. Okay, right? And does Indian subcontinent include the region of Pakistan, Bangladesh? Yes, the entirety of the subcontinent. Oftentimes, it does refer to the entire area. What name did you give to the steep western Ghats on the western side? So it is an escarpment. Escarpment. Western Ghats are examples of escarpments. It is given in the slide itself, in the PPT itself. Okay. Kindly revise the PPT. It is given in the fourth module. Okay, so please revise the PPT. Now, here, now we come to the portion of the Eastern and the Western Ghats. We have taken a look at their formation already. So here, as per the formation process, we have also discussed it, that where is it that greater amount of erosion would have happened? Where is it out of Eastern and the Western Ghats? Where do you think greater amount of erosion has happened? In the region of the east. Perfect, because it is created much earlier than the region of the Western Ghats. And the Western Ghats, because it is an escarpment, that is why it indicates a continuity of feature, and the portion thereby to the west of it has sunk underground. This is the reason why, again, another detail that I'll give you, this is the reason why here across the region of the Karnataka coastline. Let me remove that hodgepodge figure which has been created here. Okay. I will give you the basics here so that it is easier for you to revise as well. So the Chota Nagpur craton is here. The Bastar Craton was created here. This is where, in between them, you have the formation of the Garjat Hills, right? Then here you have the Karnataka Plateau, which got created. Here you had the Bundelkhand Craton, which was in existence. Then you had the formation of the Aravallis as well, right? It is here in this region where you have the Rajmahal Garo Gap, the the Chota Nagpur Craton is this, Bastar Craton is this, Karnataka Plateau is this one, and the Deccan Trap is the entirety of the area in between here. This is the region of the Deccan Trap. So slightly lesser than that, slightly here it is less. So you will find that the shape is somewhat like this. This is your Deccan Trap. Now, as I was telling you, basically, the portion across the western coastline has simply sunk due to the formation of the crack. Now, here, when you talk about this, here you will also find across the Karnataka coastline around the region of the district of Udupi, where you have the Malpe beach. There you have an island, a small island very close to the coastline. That is the St. Mary's Island. Now, that St. Mary's Island holds a significant amount of resemblance to the types of rocks that you find in Madagascar, which tells you that this portion at one point of time was significantly connected with the land, was also connected with Madagascar. So that is why St. Mary's Island indicates the past, the geological history of this particular area. And that is where it is a geo-heritage site considered to be a part of India. Okay. Now, coming to the eastern and the western Ghats. Now, in case of the western Ghats, understand the basic process here that earlier you had the landmass. Chitranshu, are you talking about the Thal Ghat, Bhor Ghat, Pal Ghat, and the Shenkotta gaps? Is that your concern, my dear friend? Important gaps in western Ghats for exam? Just hold your horses. Have patience. We will have a separate mapping module. I will give you the location of each one of them as well. Okay. So from day one, I have been telling you to hold your horses, but then obviously I'm not able to convey that. Chitranshu, is that the doubt that you have? Where is it that the Thal Ghat, Pal Ghat, Bhor Ghat gaps, the Shenkotta gap, where is it that they exist? Right? If I tell you it will be covered in mapping, will you get some amount of relief after that? Okay. So we'll cover it in mapping. Don't worry. We have a separate mapping module where we'll be talking about this. I'll show you the location there. Okay. Now, here you basically have the presence. You have the presence here in terms of the, this was the earlier scenario. Now you have the development of a crack which has happened. Yes, Ganga, that is correct. You had the development of the crack which happened here. And this portion simply underwent subsidence. So now the Western Ghats which was created, the Western Ghats which got created, they had a very steep wall-like feature. Now, what it also created was that as the rest of the area went underwater, okay, as the rest of the area underwent subsidence, it went underneath the water. So that created a wide continental shelf. Okay, that created a very wide continental shelf. Now, in this area, closer to the coastline, you will generally observe that the water is much more deeper. Very close to the coastline, the water is much more deeper because of that subsidence. Now, as the water is much more deeper here across the western coastline, that creates a condition which is very ideal for the formation of natural harbors and ports. Okay, natural harbors means harbors and ports have one basic requirement, that the ship should be able to come close to the coastline without hitting the ground. And I'm sure by this point of time, you have some logic that when we talk about the ships, they are not like your paper boats which float on water. They have a substantial portion of those ships which lies underwater as well, isn't it? So, thereby, these ships, they are always much more suitable to deeper waters. So, if you have deeper waters closer to the coastline, then the ships will be able to come much closer to the coastline. Whereas across the eastern coast, what has happened is that because it has got gentle slope, so there it is not ideal for the natural ports and harbors. There you have the port cities and various different ports such as Kamarajar port, the Chennai port, etc., which are there, Paradeep. Now, in all of these ports, you need to dig the ground closer to the coastline in order to ensure the depth for that port. Otherwise, there won't be substantial amount of depth. But in the western coastline, this is an area very ideally situated for the ports, natural ports and harbors. Okay. Now, the formation is something that we have already seen. Now, the Western Ghats, it demarcates the westernmost extent of the Peninsular Plateau. It forms an escarpment on its western slopes, thereby being able to influence the rainfall across the western coastline. Why? It forms a substantial orographic barrier. Forms orographic barrier. Okay. Now, it was formed, so that is why. Always remember, Western Ghats, they are not regarded as a hill, they are not regarded as a mountain, they are regarded as an escarpment. Okay. Now, it was formed due to the submergence of a part of land into the sea. They are locally known by different names. They are referred to as Sahyadri in Maharashtra, Nilgiris in Karnataka and Tamil Nadu, and Anamalai and Cardamom, particularly in the stretches of Kerala and Tamil Nadu, and they are higher in elevation and more continuous than the eastern Ghats. Whereas when we talk about the eastern Ghats, they are not continuous features. They are very broken. In fact, if you observe the eastern Ghats, they are not only eroded, they are significantly broken as well. And you have various different rivers, Krishna, Godavari, Mahanadi, they have eroded these areas. So there is a significant amount of discontinuity which is present. It is not as continuous as you observe the Western Ghats. So the Eastern Ghats, they run from the northern portion of Odisha through Andhra Pradesh to Tamil Nadu in the south, passing some parts of Karnataka. They are eroded and cut through by the four major rivers of peninsular India, Godavari, Mahanadi, Krishna, and Kaveri. Now, some of the important ranges here include the Javadi Hills, the Palakonda Range, the Nalamala Hills, and the Mahendragiri Hills. These are some of the important ranges there. They both meet each other at the region of Nilgiri Hills. Now, both the eastern and the western Ghats, after them and before the sea, you have the presence of the coastal plains. And these plains are created purely by deposits, deposits brought by the rivers. Now, here, over a period of time, what has also happened was that there has been a kind of a landmass in itself has emerged slightly above water across the eastern coastline, right? Across the eastern coastline, the land has slightly emerged, whereas the land has submerged across the western coastline. So there has been a slight recorrection of the tilt. Now, across the eastern coastline, because the land has emerged above water, so wherever a land lies underwater and then emerges above water, so in that area, which kind of mineral resource you find to be very common and prominent? What do you think? Which kind of mineral resource you find to be prominent? Crude oil. Very good. So that is the reason why across the eastern coastline, in certain areas, you will find the presence of crude oil, such as the Krishna Godavari basin. Okay. Now here, the western coastline is not very wide, but the eastern coastline is very wide. Why? There are a couple of reasons for the same. Now, across the western coastline, you don't have many of the rivers which are draining there. And it is a submergent coast. A part of it has went underwater. So, very little amount of deposits have happened there. But all the rivers are draining from west to east. So, not only will they be able to carry significant amount of deposits in the process, it is also an emergent coast. So, western coast is submergent. Western coast is submergent. Eastern coast is emergent. Emergent. Okay, submergent means some part has went underwater. Emergent means some part has emerged above water. So as some part has emerged above water, this has expanded the aerial spread of the eastern coast. Along with the fact, it has also led to a shortening of the continental shelf. Now, the eastern coast has always been a prized possession. Even if you read history, the ancient medieval history that you read about. So all the kingdoms, they vied for the control of western and eastern coastline for very different reasons. They wanted the control of western coast so that they could control the trade. All the trade was happening across the western coast because natural ports and harbors were present across the western coast. So they were vying for the western coast for trade. But eastern coast, they were vying for in order to have agricultural productivity, because these are made out of very fertile alluvial deposits of all the major rivers: Mahanadi, Godavari, Krishna, Kaveri. All these various different rivers, they have deposited large amount of sediments and alluvium across the eastern coastline. That is why here you could grow multiple crops of rice within the same year. That is why that agricultural productivity gave significant amount of economic prosperity in the process as well. Okay. Now, they are named by different, or they are having different names in various different areas or the spread. So, here you will find that the portion of the eastern coast to the north, this is what is referred to as northern sarkars. And the Odisha coastline in particular, the Odisha coastline in particular, that is named by, what is the name associated with the Odisha coastline? It is the Utkal coast. Very good. Then here you have the Coromandel coast. Coromandel coast. Okay. Then after that, the western coast also has got different names. Here in the region of Gujarat and some part of Maharashtra, here you will observe that the western coast is broader slightly, and that is what is referred to as the Kutch and the Kathiawar coastline. Then to the south from Ratnagiri onwards, it gets very narrow. In many areas, you will find that the coastal plains is almost non-existent. You have the Western Ghats, and then very close to it, you have the Arabian Sea. So that is where it gets very narrow, and that is where it is referred to as the Konkan coast. So the western coast is narrowest in the region of the Konkan coast. Then across the Karnataka coastline, it is referred to as by what name? Across the Karnataka coastline, it is referred to as the Kanara coast. Okay. And then around the region of Kerala, you have the name as the Malabar coast. That is where it gets very broader as well. So this is the dimension, few of the dimension. Now, western coast, it is divided into various divisions. Kutch and Kathiawar coast in Gujarat, where it is broader. Then Konkan coast in Maharashtra and Goa, where it is the narrowest. Then Malabar coast in Karnataka and Kerala, where again it gets broader. Okay, you have various different natural ports which are created here. For example, Kandla is in Gujarat, Mazagaon, then JLN port, Navasheva, Marmagao, Mangalore, Cochin, all the various different types of ports are created in the process. Okay, now western coastal plains are narrow in the middle and get broader to the north and south. Here no delta formation takes place. Rather than the delta, here you will observe the formation of estuaries. Very good. Formation of estuaries. Estuary formation we have seen earlier in the case of landforms. What is an estuary? Here you will find the formation of estuaries rather than delta. Why is it so? So basically, when you talk about, so what is an estuary? First of all, the very basic of it. So let's suppose here you have the sea and the land boundary. Okay. Here you have the river which is coming in. And then you have an area where the sea water gets in. It mixes with the fresh water. So this is your river. This is your land. This is also a land. This is your sea. So the sea water gets in. So this is what is referred to as an estuary. So rather than delta formation, you have the formation of an estuary. Why? What is the reason behind that? Why? Let us address that. So the first reason is UPSC has asked a direct question from this in mains for optional multiple times, in general studies also a couple of times. So the first reason is very good. All of you automatically are able to create the answer. That is something I like. No deposition, west to east direction, absence of vast coast, rivers have higher energy with steep slope and they don't deposit. Very good. Beautiful, guys. Very nice. Garvit, Anushka, Bhavi, Mushtaba, beautiful. And Anurag also. So let me write the reasons for the rest of you as well. So here, first of all, you will observe that majority of the rivers, they move from west to east, right? So the deposit obviously won't be in the western portion. Majority of the rivers, of large rivers, move from west to east. Okay, we are taking a look at the reason why no delta formation. Why no delta formation means there is lesser deposit, hence delta formation is not happening. If you have had a greater amount of deposit, delta formation would have happened. Like in the case of Sundarbans, you have Ganga and Brahmaputra depositing significant amounts, so Sundarbans gets created. So when you don't have that amount of deposit, that is why no delta formation. So why you don't have deposit? Because majority of the large rivers, they move from west to east. You have a couple of rivers, however, Narmada and Tapi, which do move from east to west. But there also they don't form deltas. Why? Because rivers Narmada and Tapi, Narmada, and Tapi. Beautiful. Move through rift valleys. Rift valleys. So when they are moving through a rift valley structure, what is a rift valley? Rift valley is a kind of a structure where you have a central depression of sorts. All right. So it is here that the river is draining through. So if the river is already draining through a particular depression, will it have enough amount of material which it will be able to carry? No, there won't be any vertical erosion at all. There won't be much scope of lateral erosion at all, because where will the river expand? It is very limited amount of expansion which the river can carry, right? So that means you have very limited deposits. Okay, a lack of deposits in general. So here you have the smaller rivers or streams, smaller rivers such as Mandaviya, Zuari, then you have Bharatapuya. So these are the smaller rivers which drain there. And smaller rivers obviously won't have enough amount of sedimentary load. So you have movement of very small rivers in general. Hence, less load which is carried out. Okay. So these are the basic reasons. Now, in the eastern coastline, because the rivers have moved through such a large distance, they will be able to carry large amount of deposits. So obviously there will be a delta formation. But even in the eastern coastline, you will also find estuary formation. Okay, because there also you have certain areas where the due to the slope of the land is such that seawater enters in through certain areas. So there also you will have estuary formation. Many of the times I have seen candidates, when we talk about this particular topic, they have a presumption that estuaries will be created only in western coast. No, estuaries are there in significant amount even in eastern coastline, but delta formation is not there across the western coast. So let me be more precise here in terms of the arrow. Okay, so no delta formation across the western coastline. I hope that is understood. Now, the Malabar coastline, that is the Kerala coastline in particular, has certain distinguishing features from where you will find that the seawater enters in. You have certain rivers which end up joining that seawater as well, and it forms beautiful backwaters, what are also referred to as kayals. Okay, any of you, if you have visited Kerala or even taken a look, or if you belong from the state which is referred to as the God's own country, or if you have seen or taken a look at the visuals, you will understand how visually appealing, how gorgeous all these backwaters are. But why are they created? How are they created? So understand that, yes, in the region of Alapuya, you have that. In the region of Vemban, even in the region around Kovalam, you'll find a lot of these. That is around Trivandrum coastline itself, Tiruvananthapuram coastline itself. There also you'll find a wide extension of these backwaters. So here, for everyone else, I would generally suggest to you that I understand that you will get that Bharat Darshan facility once you visit the Labasna once you get selected. But if you get an opportunity, do utilize the opportunity to travel, if possible, by train from the region of Mumbai to the region of Kerala by train, because that is where you get a chance to move through the visually appealing Konkan railways, which in itself is an engineering marvel, where you will be moving parallelly with the sea and you will be witnessing the marvel of the Western Ghats. You will be observing many estuaries Across the railway line itself, you will observe the estuary formation, right? And then obviously if you visit Kerala, then in itself is a beauty to behold. Okay, so here, when you take a look at it, so why is it that these backwaters they get created? So here you will observe basically that in areas, let's suppose if I give you the side view in particular, so if the side view is here, this is the coastline. Okay, this is the seawater. This is the side view I'm giving you. So the seawater and the coastline are almost at the similar level, almost without any change in elevation. Now let me give you the top view. Now it can happen that in certain areas, if you take a look at the coastline from top, here you have the sea, here you have the land. Now in certain areas, this coastline might have a lower elevation, might have a dip associated. So what will happen? Let's suppose here you have a dip in this particular portion, and then again you have land. So what will happen? The seawater simply enters in. The seawater simply enter. This is the seawater here. So the seawater simply enters into this place, right? It will enter wherever that depressed area exists. Okay. Now, many of the times you will find that this gets connected to a small stream of river, a small stream of river. That is where it gets connected. So this is what is referred to as a backwater or kayal in the region of Kerala. Now this backwater, what do you think will be the salinity? Salinity will be high, or will you have fresh water here? What do you think? It will be saline water, brackish, in between the very highly saline ocean and fresh water. It will be somewhere in between. It is the brackish water. So that is where you have the very famous boat race also, which is held every year, and these are very good for fishing activities. If ever you witness this, you will observe that many of these areas, they get temporarily disconnected because of sand deposits which happen. But then again, during the conditions of the high tide, you will have more water which flows, and there's a connectivity, right? So there is a significant amount of fishing activities. More importantly, here you will find a very lush green mangrove vegetation with great diversity to be growing here. So very good for biodiversity and the stretch of biodiversity as well. Yes, the Nehru Trophy. Okay. So that is the property of the western coastal plain, right? Now, why saline water? That is because it is a seawater which is coming in, isn't it? That is backwater, means water which is coming back. Hence, the name backwater is associated. Okay, so water is coming from sea, and that is why the property of seawater. In fact, you will find certain of these backwaters even in the region around the Karnataka coastline. That is around the deltaic stretches as you move between the area of Kundapura on one side to Udupi on the other side of across the Karnataka coast. And those of you belonging from Karnataka would attest to it. So there also you'll find narrow streams of these backwaters where you have very beautiful hanging bridges. Now, the wooden arch bridges which are completely suspended, and it is again something to behold. So if possible, try to visit these places. It is again a treat. And what is the difference between estuary and estuaries are much larger, and backwaters, they can have a kind, they are narrower, they can have a connect. Okay, estuaries, you will find a lesser distance or a lesser existence between the river and the sea. Whereas in the case of these backwaters, sometimes they can get connected with the river, but many of the times they might not be connected to any river at all. Okay. Now, then we come to the eastern coastal plain. The eastern coastal plain overall, basically it is emergent coast. We have talked about it, and it is broader because of significant amount of deposits which have been carried out. Here you will find very well developed deltas which are created. And just so that you don't have or commit a mistake, estuaries are also created, are also formed. Okay. Now, it is known as Coromandel Coast in Tamil Nadu, very fertile. And here you have the deltas of Mahanadi, Godavari, Krishna, Kaveri. All of that is also created. Okay. Now, here, before we move to the island groups, I want you to have another area from where questions are frequently asked. And that is about what is written in small letters. It is written estuaries are also formed. Vivek, kindly note it down. It is written estuaries are also formed. So here you will find that there are frequent questions which have been asked about the areas of landslide, up from the portion of landslide. So we have talked about Himalayas, we have talked about the Western Ghats. Now, even in the region of Western Ghats, you do experience frequent landslides from the region around Wayanad to the region around, let's say, to the south of Chiploon, around Ratnagiri coast. Also, you experience landslides. But in Himalayas, you experience it in large areas from Himachal, Uttarakhand, Sikkim, Arunachal, everywhere you experience the landslides. So, landslides are very prominent in the region of Himalayas as compared to Western Ghats. So, this is something that UPSC has asked multiple times. That is, why more landslides occur in Himalayas as compared to Western Ghats. Let's think about the reason of this. I'm sure all of us, we already know the reason. It is just about compiling it. Convergence and divergence of plates, absolutely not. High seismic activity, yes. Steep slope, good. Tectonically active, good. Higher flow of rivers in the Himalayas, good. Then heavy downpour, okay. More frequent cloudburst, more apt and more precise. Then, okay. So mostly we have talked about it. So here you have in the region of the Himalayas, they are unstable landmass. Himalayas are unstable, means seismically active. That means prone to earthquakes. So whenever an earthquake occurs, slope destabilization is observed. Why is it seismically active? Because of the movement of the plates, due to plate movement. Then after that, you also have Hogback topography in the region of Himalayas. Very steep southern slope. That is why you will observe majority of the landslides, they occur across the southern slope of the Himalayas. Very steep southern slopes. Okay, so when you have a very steep southern slope means the influence of the gravity will be very high. Then large scale deforestation. Deforestation in Himalayas, which leads to soil becomes loose and free to move. Then after that, frequent occurrences of cloud bursts. Cloud bursts in Himalayas. Frequent occurrences of cloudbursts in Himalayas. So you have very high amount of water flow suddenly happening, due to which you have the soil which is ready to move. Then after that, rampant construction activity, and that happens because of two: infra and tourism. Both of them will lead to weakening of rocks across the slope. Then after that, you will also observe large number of streams and rivers drain through the region through Himalayas. Okay, large number of streams and rivers, they will drain through the region of Himalayas. The three thrust faults, everything you can talk about in the case of the seismically active portion itself. Hogback, yes Gulam, that is a good point. Hogback, so okay, yesterday only we discussed about hogback topography. Hogback means that on one side it is very steeper, on the other side it is gentle, right? So Himalayas, because of the thrust provided by the Indian plate, is much steep on the southern slope. It is very gentle across the northern slope. Okay. Now, then after that, mining activities, activities also weakens the slope. In the region of the Shivalik, very good. And this is a point given by Shubha. So, in the region of the Shivalik, you have the presence of soft sedimentary rocks, because the Shivaliks are created as a result of the upfolding of the unconsolidated deposits brought by the rivers originating from the Great and the Middle Himalayas. So, in the region of the Shivaliks, you have region of shivaliks, soft rock, rock structure, prone to easy movement, easy breakage and movement. Okay, then the glacial movement also will induce some kind of avalanches where this due to global warming there's increased melting of snow and ice. So in many areas you will observe that the ice in itself starts falling. Okay, so these are the various different reasons. This has been asked as a 10-mark question as well. This has been asked as a 15-mark question as well. Cloudburst, we have already mentioned. Okay, so here you have to be able to elaborate on these points. Don't simply list these 8 to 9 points and be done with it. Each of these points, I hope you have the ability to write 2 or 3 sentences from it. That will be more than sufficient. Okay, now then we have the region of the island groups. Shifting cultivation, it will all come under the portion of deforestation itself, Chitranshu. All of this will come under deforestation. So here, when we talk about the island groups, so India is blessed strategically with the presence of 2 island groups, both in the Bay of Bengal as well as in the region of Lakshadweep. Now, both these island groups, they owe their origin to very different factors and conditions. While the region of Lakshadweep we have seen, they are coral islands. Lakshadweep, they are Maldives. Maldives is in India. Okay. No, my dear friend, Maldives is not in India. Okay. These are coral islands. Okay, by the way, because few of you are asking, Mansi, you are asking. So, I have already discussed about the subduction or the sinking which is happening in Joshimath. Do we have an idea why Joshimath is the region which is undergone sinking or is undergoing subsidence? We have the reason for that. Perfect. Good. So, yes. So we have discussed this already. I will give you a brief recap. Joshimath basically is a kind of a deposit. It is the city or the region lies on a deposit. It is not on a hill. It is not on a mountain. It is on a deposit of a product of landslide. So when the landslides happen, you have all the soil and the rock which comes over. So imagine if you have a landslide which is happening. Let's suppose you have the landslide which is happening here from this area. You will have materials which will sink here, and those materials will pile up in a region, right? So these are your landslide deposits. So here you will have unconsolidated rock and soil structure mixed with each other. So obviously not a very stable landmass. It is on this landmass where you have the Joshimath, the city of Joshimath. But then not only that, now due to multiple different or huge amount of construction activities which have happened, they have laid immense amount of pressure, and the stress is created on this landmass where it simply is unable to withstand that. Had it been a stable landmass, it would have withstood that construction pressure, but it is unstable. Here you have rocks underneath them, you have loose soil underneath them, maybe again rocks underneath them, again soil. So when you apply pressure on that, the soil will simply give way, and that is why there is sinking due to the heavy pressure. also induced by the fact that due to cloudburst and frequent cloudburst activities which happen, you have a high amount of rainfall. Many of the seasonal streams which come into that area, and these seasonal streams, they associate a kind of a flow to the soil as well, due to which the soil is not rigid anymore. The soil is very flexible and is ready to move, and that further adds to the ability of the soil to uh, in a way capsize under the huge pressure induced by the construction. Then you also have the NTPC project which is being implemented here, and the Vishnugad Tapovan NTPC project which is being implemented. So that has blocked the movement of the river. So when the river movement is blocked, the river starts to throw in water all around. It starts to fill in water all around through the soil, through the rocks. Water starts to percolate. All this has added to the increased movement and lack of uh, the dense vegetation. Earlier, you had dense vegetation in that area, so it would bind the soil very significantly, not allow the soil to move. Vegetation holds the soil. But once you cut down the trees, you replace it with the small plants and you construct buildings. So the soil is then ready to move. So all this has led to Joshimat crisis. Now, coming to the portion of Lakshadweep, they have been created as a result of corals, and they are basically the coral islands. Few of the islands, even in Andaman Nicobar, they also have their origin associated with corals in a way. But when we talk about the region of Andaman Nicobar, they are volcanic arc islands. Arc islands. They are created as a result of convergence of oceanic crusts. Which oceanic crusts are we talking about? That is the oceanic crust of the Indian plate, along with the oceanic crust of the Burmese plate. Crust of Burmese plate. Okay. So both of them are converging, and it is because of that convergence, if I can take you back to this image, you will observe that, and we had discussed it yesterday itself, that there is a kind of a eastward push of the Indian plate. There is a kind of an eastward push. Now that is why the rocks are much more compressed in the northeastern part of the Himalayas, and also you have the presence of the folds across the east. Now that fold across the east, it continues through the Arakan, Yoma Pegu, Yoma ranges, Tanasarim ranges. And observe, it is here that you have the oceanic convergence. So observe the kind of an arc which is created, right? In fact, you have a small trench also which is created in this area. It is considered to be very much a part of the Indonesian arc. Indonesian arc, if you will observe, it does have a significant amount of extension. So it is created across that region of Indonesian arc. Now here you will observe that because of this oceanic convergence, you also have volcanic activities. That is why Barren Islands, being the only active volcano across the country, lies across this volcanic arc. So here you will observe that you have a basic kind of convergence. Let's suppose you have the presence of the sea water, right? Here you have the movement of one of the oceanic plates. You have the Andaman Trench as well, the minor one. Okay. As this goes down, eventually it will melt. The molten portion will rise up, forming a kind of a volcanic formation. It is these formations which will continue to increase in height, forming a series of islands across this entire zone of subduction which is happening, thereby creating this kind of an islandic feature. Now, here it can also happen that in certain areas you have the creation of the seamounts, and these seamounts will later experience the growth of corals. That is why when you visit the region around Havelock, the Havelock Islands, you will observe that you have many of the small islands which are also coral in origin. So here you will have both corals and volcanic, but most of the islands, they are volcanic in nature. Okay. Now, then after this is the portion. So that completes the portion of Indian topography and Indian physiography. Now after this, we'll come over to the portion of the drainage system. Okay. If Andamans is the extension of Arakan Yoma, Andamans is not an extension of Arakan Yoma. Andamans is basically, it is said in certain cases to be an extension, but it is a different entity created across the. So take a look at the world map and try to, with the help of a pencil, try to draw a line connecting Andaman, Nicobar, and Indonesia. You will observe that it is an arc. So across Indonesia also you have many volcanic origins and volcanic eruptions which happen. The Barren Islands is considered to be the northernmost volcanic eruption of the Indonesian arc. Okay. And yes, Sakshi, sometimes. The coral part of Andaman. So coral part of Andaman gets created when you have a seamount. On top of the seamount, let's suppose you have the growth of corals and the seamount doesn't extend anymore, then you have the coral islands. Okay. Now, questions asked from these two islands. So questions are asked from the portion of, for example, the why the Himalayas have greater amount of if I tell you the types of portion questions which have been asked from this area, why Himalayas experience greater amount of landslides, this has been repeated multiple times. Last year, there was a question asked about discuss the properties of Deccan traps, right? Now, many of us, we have referred to or we have read the portion of Deccan traps only in the basics of NCRT, where it is written that this is the extent of Deccan trap. But if you know the formation, now I hope you will be able to talk about the properties of Deccan traps, how in between these layers it also traps some amount of minerals and various other areas. This, how is it that the trap has been created, why it is referred to as a trap, all this detail I'm sure you will be able to talk about, isn't it? Which previous slide? This previous slide. Okay. Then you have to the landslides, then Deccan traps, then why is it that the western coastline experiences the formation of estuaries rather than deltas? This is a question which has been repeated multiple times in optional as well as in general studies mains. Okay. Why is it that the continental shelf is wider across the western coastline as compared to the eastern coastline? These are the questions which are asked. Now, in the present day context, you can always have a question which is commingled with the part of environment and ecology as well. So you can have a question about the coral islands such as Lakshadweep. You can talk about, or you can have a question that why Maldives, which is very close to it, Lakshadweep islands, Maldives earns billions of dollars in revenue out of tourism, but Lakshadweep is still not able to do so because there is obviously lack of connectivity, lack of infrastructure, critical ecosystems which need to be managed, and that is why you don't have the development. Okay. We need to show location, yes. Okay. Right. Landslides are predictable or not? Yes, they are. The zones are predictable. When the landslides will happen, that is not predictable, but the zones are predictable. And you have a landslide atlas of Earth as well, of India as well, where the very frequently prone areas to landslides, they are demarcated. Okay. Are continental plains formed by deposits over continental shelf? Yes. So now we come to the drainage system. So here let me talk about which are the areas relevant for your prelims and which are the areas relevant for your mains. So for your prelims, you will have areas such as drainage pattern, major rivers and their tributaries, rivers and tributaries, the cities through which they move, through which they move. Okay. Now, now here also I would suggest to you that restrict yourself to those which are in relevance in current affairs. You will find those particular things in discussion. Okay. So these are the areas, and for the mains, you have portions such as flooding of Himalayan rivers, and also interlinking of rivers, pros and cons. So this is the kind of question which can be asked in prelims and mains. Okay, and we will be discussing upon that after the break. So we take a break and we'll be back by 7, and then we will continue. So let's take a break and we'll be back. A confirmation about the audio, please, guys. Thank you. Why are Western Ghats having larger coastal area even though the land? Which larger coastal area are we referring to here, Mayank? The coastal plains are narrow. The Ghat section is continuous as compared to the Eastern Ghats because it is much newer, and that is why lesser amount of degradation. Why Eastern coast is emergent? Because some portion of it has come above water, and after the last ice age, some portion of it has emerged above water. That is why. Okay. Okay. So now we initiate the discussion about the drainage systems. Now, what do we mean by drainage systems? Overall, when we talk about drainage, so as soon as an area gets created, as soon as an area comes into existence, now after that, due to concentration of the amount of rainfall happening in an area, due to various other factors as well, you will observe that there is a movement of water, right? Now, let's suppose a particular region has come into existence, a new land area, let's suppose, has been created. Now, when the new land area gets created, over a period of time, there you will observe the movement of water. Now, that movement of water which will be observed will be, in a way, dependent upon the slope topography, will be dependent upon the nature of the rocks as well. Because if, let's suppose, you have sedimentary rocks which are present all around, now the amount of erosion which can be carried out will be very significant. But if you have only the presence of igneous or metamorphic rocks in a particular area, the there will be a greater difficulty which will be experienced in carrying out erosional processes as well. So that is why the drainage system in a region is a product or is an outcome of the type of rocks, whether the rocks are new or are they old. Where is it that you have a greater flow of water? For example, when we talk about the Himalayan region, now there the rivers, they have the presence of water all throughout the year, right? And the rivers, they have the presence all throughout the year. Why? Because of the melting of snow and ice. Whereas when we talk about the peninsular rivers, now the peninsular rivers, they are not having the same flow of water throughout the year. There, during the rainy season, suddenly the water level will rise up. Suddenly the rivers will have excess flow. But then during the dry season, you will have lesser flow. Why? Because in the region of the peninsular area, the river movement or the water from the river, water which is present in the rivers, is not because of melting of ice and snow, but because of concentrated amount of rainfall happening in certain stretches. So that is where drainage system is basically dependent on the local topography and local geography. And by the way, guys, here when we talk about the drainage systems and the drainage pattern, regardless of whatever I say here, you guys will have a certain level of anxiety associated when you talk about the types of questions that UPSC has asked previously in the prelims, and that is quite natural. So let me tell you, or let me again clarify certain basic points. So the areas that I have told you is relevant for the prelims. So from there, you can have certain factual questions which can be asked. Sometimes you will find very random kind of questions associated with, let's suppose, the portion of origin of rivers, etc., which are asked. Now all that detail is to be provided, is present in the region or in the portion of additional reading materials as well. How many of us are referring to the additional reading materials here? Are we taking a look at the additional reading materials? Good. So please do refer to those additional reading materials as well. You will get the idea about the origin of the rivers, the various different details associated. But please keep an eye out for the portion of current affairs. And when I say current affairs, see, that is why I tell you to read the newspapers, because when you read the newspaper, oftentimes many of the small streams, many of the small flows, they are mentioned there, which you don't find in the various analysis, etc. So when you keep a track of those portions of current affairs, and if you follow the same approach that we discussed in the initiation of the class, that how when you have come across any new name, any new aspect of the name in terms of the geographical location, geographical area, river stream, any phenomena, immediately open up the atlas. Immediately. Take a look at the location. If atlas is something where you are unable to find something, don't worry about it. Don't go to the market that I will buy a new atlas. Take the help of Google. Okay. But that is something which should be imprinted in your memory. So if you follow that aspect and that approach, you will never be perturbed by the type of questions and never chase the factual questions out there. When you analyzing the PYQs, please don't end up chasing the fact based or the factual questions. In fact, I will take this opportunity to tell you the approach for the portion of prelims as well, that many of us, we get worried when we take a look at certain factual questions that UPSC is going to ask these factual questions only, and we base our preparation dependent upon that. But if you break down the portion of the questions asked in prelims, out of the 100 questions which are asked, 100 questions which are asked in the prelims, even UPSC doesn't expect you to break through all those 100 questions, right? Out of the 100 questions which are asked, in fact, I will use a new slide for this. So if you break it down, 100 questions are asked in the prelims. The cutoff nowadays is largely in the range of 85 plus minus 3. That is the cutoff, right? So that means in effectiveness, you have to get 45 correct questions and you are through. Okay. Don't have an aim that I will score 150. Nobody is bothered about whether you score 140, 150. Get through the prelims, prepare for the mains, and get through the examination. Okay. Now, out of these 100 questions which are there, you will find that 40 to 45 questions minimum, 40 to 45 questions every year, regardless of whatever hue and cry is being created about the questions being tough, etc. These questions are from the basics of the concepts of polity, economy, geography, history, environment, etc. These are the questions that you have to target. So out of the 40 to 45 questions that you target, if you have revised the portion of the basics multiple times, then here you have to aim that you will be able to target around 42 43 out of them, and at max. Now even if you are sure, very sure about a question, you will commit mistakes there. So that is a given. So mistakes will happen. You won't find any individual out there who will tell you that I attempted 45 questions, all of them are correct. If someone tells you, stop having contact with them, because they are lying to their teeth. Nobody is going to have 100% proficiency. Here what the preparation will do is ensure that maximum negative, 5 negative, not more than that. So if you ensure 5 negative and not more, already you are in the range of 75, somewhere around 75 marks you are there. 85 plus minus 3 is the cutoff. Now, then you will find after this around 25 questions which are logic based. Logic based. Logic based in the sense that you would have heard about the concept somewhere, but you would not have come across the kind of variation of that concept in the question that is given in front of you. You would not have found the type of options which are mentioned. So this is driven by logic. It is this portion which UPSC is extending and expanding every year. Okay, so out of those 25 questions, ideally target, you need to have around 15 to 17 attempts. Okay, here also you will commit some mistake. So roughly assume 10 to 12 minimum correct. For example, let's suppose, example of logic based, let's suppose you have an example about the question about the wildlife act. Now you have not studied about the details of the wildlife act, but you know that in schedule 6 you have the plants, so that is the exception. So this is where it is heavily dependent on current affairs as well. This will have current affairs relation. So in total till now, how many correct questions you have attempted? So around 40 from the earlier one, or let's suppose 37 from the earlier one, 12 after that. So till now, close to around 49 to 50 correct you have already attempted. Okay. I'm not saying that you will be able to attempt all the 25. You will be able to attempt only around 15 to 17. Then after that, you will find 20 to 25 questions again, or sometimes even more. This is the portion which has increased. Earlier, this used to be 50 to 55, but with the changing pattern, this has come down. These are current affairs fact based. Affairs fact based. And logic based solving doesn't mean only elimination. It also means understanding what is the demand of the question, and also means applying your logic that whether this can be correct or not. So these are very factual. Very factual. If you are good in the portion of current affairs, then ideally you should be able to get around 10 to 15 out of them. Okay. Now, here, even if this portion takes a hit, please don't worry because of that, because you have already secured your cutoff by the earlier two. Your cutoff is already clear. This is just an added bonus. The problem starts when you base your entire preparation dependent on these fact based questions. Please don't base your preparation on these fact based questions. Okay? These are not repeated year after year. This year, you might have a different fact which is asked. For example, UPSC had asked about the minor minerals in terms of the mineral deposits. Now, next year, all the students, they started learning about all the major and the minor minerals. It is very tedious to remember all of that. Now, UPSC has not asked that again. Then UPSC asked about the lakes across Africa. Now people have started learning all the lakes across the entirety of the world. UPSC will not ask it again. So these fact-based questions which appear from history, geography, these are the areas where science and tech, absolute fact can be chosen from any part. Right? So please don't base your preparation and never be disheartened by a question which is fact-based. That is not on which the portion of cutoff is decided. Cutoff is decided based on this. I'll tell you what is the problem which emerges. When, as a candidate, we analyze the PYQs, we commit mistakes in this one. We are okay with that. That, okay, we will study that and we will get it right. But that doesn't happen. We continue to commit mistakes here. It is the mistakes that you commit in these basic questions which puts you out of the race. Because these fact-based questions, nobody knows about it. Okay, none of the candidates know about those fact based questions. A question such as whether an orangutan uses a stick to take ants and use it as a source of food. Now, if anybody has watched a documentary, fair enough, they would be aware, but that proportion would be very, very less. 10,000 people get selected for the mains examination. So I can give you in written that and writing that the 99% of those candidates are not aware about these fact based questions. They have some guesswork where they get 4 to 5 or 10 or 12 of them correct. That is a different matter altogether. But the cutoff is decided based upon these two. Okay. So always when I say prepare as if you are going to appear for the mains examination. I am asking you to prepare for these. This will always be there. Please don't ignore that. Okay, so that goes true for all the fact based questions, even in history, even in science and tech, even in environment, even in the case of geography. Rather than chasing the facts of the previous questions of the previous years, chase the basics, the basic questions which have been asked, and whether you are able to follow them or not. If there is a discrepancy in that, then raise an alarm. Okay, this is to help you understand the pattern of prelims and the changing pattern of prelims. You should know your enemy before moving into the battle, and enemy right now is UPSC. So get into that mindset. Okay, so I hope you are aware about how to approach the prelims examination, because as of now this is the biggest anxiety source of anxiety for almost all the candidates, that how will we handle the prelims based questions, and you are telling us to prepare for the mains, but what will happen to the prelims? I want you to understand what you are preparing for. If you blindly simply go with the brute force, one time you might get lucky, but all the other 99 times you will definitely fail. But if you break it down, that is why when you will assess and attempt for the test series, break down those questions in the category that, okay, this was a basic concept based question coming from the area that I have already known about it, so why am I committing mistakes here? Whether there is a lapse of concentration, whether there is a lack of information, concentrate upon that. Okay, so try to have this in positive aspect. Any issue here? Right, the question I did correct, others could not. That's so, Garvit, that is the case. Basically, you will find that in those factual questions, you get two or three of them correct, three to four of them correct, and the rest of the field gets that incorrect, all of them. And there we get the confidence that we deserve to get through the examination despite the mistakes that we commit in the basic portion. So just concentrate on this. I'll tell you where another problem and fallacy lies. Out of these 45 questions, if you start preparing and attempting now, you will be committing 10 to 15 errors, 10 to 15 negative marks. That is something which will definitely put you out of the race. Then you are supposed to cover a very large distance in these areas, which is simply impossible a task. Okay, so please have that clarity and then move ahead with your preparation. There is no reason why, after covering so much sources of information, after having such a broad idea, there is no reason why you should not be able to clear this examination. I'll tell you, in fact, in the mains examination, I have kept a track of the, if possible I'll show you the chart as well. So basically for the past few years I have kept a track. Around 105 marks worth of questions are asked in the GS paper 1 for mains from the portion of geography every year. On an average, 80 to 90 marks are directly taken from the PPTs and the matters which we have discussed in the class. So elevate your level of preparation. Prelims, you might succeed this year, you might not succeed if it doesn't go in your favor. But if you have prepared for the mains, the moment you succeed in the prelims, you will secure a good rank. There is no scope for elimination after that. Okay. And 40 to 45 question is asked from CSAT. CSAT is a different paper altogether. I'm talking about the GS portion, my dear friend. Optional, same pattern is given. Optional, you don't have MCQs. Optional is the subjective test. First thing that you need to do is understand the pattern. Many of us are not clear where you have the multiple choice questions, where we have the subjective questions, where we have the essay paper. So I have had the opportunity of taking the essay classes. I had a couple of candidates asking me that what are the kind of prelims questions asked from essay. So first of all, get a very clear mindset of what are the type of questions, what is the pattern that is expected out of you, and then it will be better. Okay. And Yes, Anurag. In the case of forest services, the only tough portion is getting through the prelims. That margin that you need to have for prelims, that is the only tough portion. Optional areas for the forest services, they are not very tough. The questions are very basic, and the cutoff also goes lower. Okay. CSAT is qualifying paper. You need to get 66 out of 200. Now, after that, here, when we talk about the drainage systems, now we come back to the portion of drainage systems. I hope this has given a kind of a conceptual clarity for you, that how to approach not only the subject of geography but other subjects as well. I understand many of you have written mails to me about the anxious moments that you share about certain topics of history, certain topics of science and tech, etc. This is just to assuage your level of anxiety, so that you calm down, you understand what is required, and you work accordingly. Okay. Now, when we talk about the drainage systems, basically drainage systems are an outcome, the sum product of the topography, the local topography that you experience in a region. So flow of water through a well defined channel, that is referred to as a drainage. A network of such channels, that is referred to as drainage system. Right, network of different channels, that is the drainage system, which is a sum product or an outcome of the topography, the gradient of the land, the geological period, that is how old a particular landmass is. So the older the landmass, easier it is to erode, easier the river will be able to find any which way that it wants. Newer the landmass, the river will find it very difficult to erode. Nature and structure of the rocks, softer rocks will be eroded easily, hard rocks won't be eroded significantly. Amount of water flow and the periodicity of the flow, whether the flow is same throughout the year or the flow is enriched only during the portion of the rainy season. Now a river actually drains the water collected from a specific area, which is called its catchment area. Catchment area is from the entire region that the river gets its water from. So let me have that with the help of a very basic. So optional subject as of now, no. Shiva, no. IFOS, you have to take two optionals, yes. No, cutoff is only different from for the civil services and the forest services. That's it. Let's suppose we consider this particular region in general. Now, here, if we observe the movement of water from this region, let's suppose. Now, let's suppose here the river is draining into this area. Let's suppose because there is a melting of ice and snow which is happening. Let's suppose this is a peak which is covered in ice, and it is the melting of that ice and snow which is filling in this particular river. It is this ice and snow which is melting up and which is filling slowly and steadily the flow of the river. That is what it is dependent upon. Now, here, the water in the river, it is not only going to be dependent on this melting of ice and snow. Let's suppose there is a kind of rainfall here, a good amount of rainfall which occurs in this region. Now, where will the water go? The water will form a kind of a seasonal stream or a small stream here. It will also add on to the main river itself, isn't it? It will also add on to the main river. Let's suppose there is another smaller river or a stream which is originating from here. And here also, due to the slope, the water ends up mixing with the main river itself. So we can say that the water in the main river is getting accumulated from all the surrounding regions rather than only this icy peak which is melting. So this entire area from which, including the tributaries, this entire region from where the water is moving into the main river, that entire region will be the catchment area. That will be your catchment area. Okay. That is what is referred to as a catchment area. Now, here, if I show you the better image of this, so this is the better image in the sense the computer drawn image basically. So here you will observe that the water in this river is drained even if it rains here. So all that water will accumulate, it will move into this river, isn't it? So that entire region is the catchment area of the river. Now, the drainage basins that we have, they are divided from each other by the topographic barriers, which are referred to as a watershed. So, topographic barriers. So, let's assume that in a particular area, let's assume that you have the presence of the barrier in the sense. Let's assume here you have a kind of a ridge like portion, and this continues here. Now, now, if you have a mountainous system here, a system of various different mountains here, and you have a system of mountains and hills here as well. Okay. Now, if a river originates from here, from this portion, this river, it will never be able to cross this topographic barrier. This river will have its drainage somewhere here. And if a river system originates from here, this will again not be able to cross that topographic barrier. It will have its drainage, all the tributaries, etc., will be having a flow accordingly. All these tributaries, etc., that you see will be having its flow accordingly. Here also, all the tributaries, etc., will have a flow in a different direction. So these two drainage basins, they are differentiated by a topographical barrier, isn't it? This is a kind of a topographical barrier. Topographical barrier, and this topographical barrier, it separates the two drainage basins. It ends up separating the two different drainage basins out there. So this topographical barrier is what is also referred to as a watershed. Okay, that ends up separating the two drainage basins. Now here, for example, for example, if you observe the movement of river Ganga and the entirety of the Indus river system, you will observe that for a substantial portion, the movement of all the river and the streams, be it of the Ganga basin, be it of the Indus river basin, both of them, they are in the same northeast to southwest direction. But after that, river Ganga moves to the east and river Indus continues to move further southwest into the region of the Arabian Sea. So there is a dividing barrier in the region of Ambala, where the land is slightly uplifted. And that is where Ambala Divide, very good, Ambala Divide differentiates, or rather than differentiating, separates the Ganga basin from the Indus River basin. Catchment and the basin is not the same. Basin consists of the area of the river and its tributaries. That is it. That is the drainage basin. So they are not the same. Okay. So that is the example of the various different types of watershed that you have. For example, another watershed that you have to think about, then Western Ghats also acts as a watershed. Western Ghats and their elevation, that differentiates the water moving towards the east and the water moving to the west. You have the small streams which originate there, they move to the west into the Arabian Sea, whereas you have many large streams which originate, they are unable to cross the Western Ghats and they simply move down the slopes. So Western Ghats is also an example of water divide. So another example you can take of Western Ghats, that is also a water divide. Okay. Now, then when we talk about the flow of the stream, one thing that all of us would simply understand without much of a complication is that the streams or the rivers, they will always move from a greater height to a lower elevation. You would never have come across a scenario where the water is moving from a lower altitude to a higher altitude. Always water is impacted by the force of gravity. However, based upon the flow, you have the classification of the stream into the sequent and insequent. And on what basis is that classification made? So that classification is made on the simple basis that certain streams, they appear to follow the slope of the land, whereas certain streams, they appear, even though they are moving as per the slope, they appear to defy the slope of the land, right? So those which appear to follow the slope of the land, they are referred to as sequent streams, and those which appear to defy the slope of the land, they are referred to as insequent streams. So the sequent streams, they appear to follow the slope of the land, to follow the slope of the land, whereas when we talk about the insequent streams, they appear to defy the slope of the land. Okay. Now, there also, in the case of sequent, you have the consequent and subsequent. And then in the case of insequent, you have antecedent and superimposed. Now, consequent is the one which is said to have come into existence, which is the mainstream and the master stream, as it is referred to. That is supposed to have come into existence after the origin of the landform. When the landform would have been created, then the stream would have come into existence, and it is a major stream. Subsequent, what is the meaning of the English term subsequent? After an event, after something has happened. So, subsequently. So, subsequent means a stream which has come into development, come into existence after the mainstream, and ends up joining the master stream or the master consequent. This is also referred to as the mainstream or the master stream. master stream. Okay. Now, in the case of the subsequent, you will observe it has come into, now this is a point of contention for many of the geographers, because many of the geographers and geologists, they hold the opinion, and a very strong opinion for that matter, that even these subsequent streams, they also must have or might have come into existence at the same point of time. But here they end up joining the master stream, end up joining the master stream. Okay. We'll take a detailed look at each one of them. We'll take a look at the examples as well. So consequent, they are the streams whose course is a direct consequence of the original slope of the surface upon which it has come into existence. That is, the streams that follow the slope of the land over which it is originally developed. So the same image I'll take the help of, the image which I had indicated earlier. So let's suppose a stream has come into existence immediately after the slope. After the slope has been determined, a major stream has come into existence. Now, this will be referred to as the master stream or the master consequent. Master consequent stream. Whereas it can happen that, let's suppose, another stream has come into existence, maybe at the same time, maybe sometime later, but then it also ends up joining the mainstream as well. It is also going to follow the and adhere the slope of the land. It appears that it simply follows the slope of the land. So this will be your subsequent stream. Okay, this will be your subsequent stream. Okay, so you have the master consequent and you also have the subsequent stream. In both of these cases, you will observe that they appear to follow the slope of the land. Very simply so, they appear to follow that slope. Okay, so here example can be taken of consequent. You can take the case of river Ganga. Any of the tributaries of river Ganga that you consider can be considered as a subsequent. So example, river Ganga. That can be considered to be the example. Then we come to insequent streams. They appear to flow opposite to the slope. Insequent streams. So here, when you take a look at the insequent streams, basically here, for example, let's suppose you consider the mighty Himalayas, all the various different ranges spread across a large distance. Now, if you consider rivers such as the river Indus, if you consider the rivers such as river Satluj, river Brahmaputra, river Kosi, now these rivers, they manage to cut through the Himalayas. Now, ideally, if you have a major mountain system and a river is originating here, the river should change its path. The river will never have the capacity to simply erode through the mountain system and get rid of the mountain system in itself. Particularly as massive a mountain system as Himalayas, the river will never have the capacity. But you have certain rivers, such as Indus, such as Satluj, such as Kosi, such as Brahmaputra. Now, these particular rivers, they appear to defy the slope in the sense that they are cutting through the massive mountains of Himalayas and they form very deep gorge. So that is why it appears as if they are defying the force of gravity in general. And that is where it appears they are defying the slope of the land. And they are referred to as antecedent. Antecedent, what is the meaning of the term antecedent? Something which is in existence before an event, right? So antecedent. So these are those rivers which would have been in existence prior to the formation of the Himalayas themselves, and they would have drained through the region. And that is why, even as around them the Himalayas continue to get uplifted, the rivers have maintained their flow. Just like, remember the kind of impact that entrenched meander and river terraces that we saw, where the surrounding land kept on getting uplifted, but the river continued its motion, continued its flow. So the same thing is experienced in the case of antecedent as well. So here, insequent are of two types. You have antecedent as well as superimposed. Both are insequent streams. So let's suppose here you have a slope, a particular landmass, let's suppose, where a river is flowing. Now, if the land experiences an upfold here, if it experiences a folding action, let's suppose here, in this entirety of the stretch. Now, the river bed, that will not get folded. The river bed will continue the process of erosion. Any upliftment happening on the river bed, it will be able to erode. So the river will continue to follow its path. So if, let's suppose, the river is flowing like this, as you can see, as this region undergoes compression and the region is uplifted, now there you will observe that the river continues to erode any kind of upfold that is happening all around it. The land simply gets uplifted. So this river is in existence before the existence of this fold landmass, and that is why it is regarded as antecedent. Antecedent example, you can have example river Indus, river Satluj, then even river Kosi, right? These are examples of antecedent rivers which are out there. Then comes the superimposed. Now, superimposed, if you take a look at it, now before talking about the definition and confusing you with the portion of the definition, let me start with the basic explanation here about the superimposed. It is again and a kind of an insequent river stream. So, superimposed. Drainage. What is the meaning of the term superimposed? It basically means something which has been kept on top, above the existing surface, something which has been kept on top. Now start applying your logic one by one. I will ask you the questions of logic. Start applying your logic. So let's suppose you have a landmass which is having a kind of a pattern somewhat like this. Let's suppose it is made up of hard rocks, hard igneous rocks, let's suppose. Okay. Made up of very hard igneous rocks. Now, if I ask you the basic question that in this region, the most likely place for a river to be flowing, let's suppose, is this one or this one. If I name this one, if I name this two, which is the most likely place for the river to flow? Very easy. The low-lying region, that is two. That is where most likely the depressed area is where the river will have its flow. Now, the river is not in existence at this point of time in history. where you have only the presence of the hard rocks, the river is not in existence here. Okay. Now, these are made up of your hard igneous rocks. Hard igneous rocks, very difficult to erode, almost impossible to erode. Okay. Now, let's suppose this is the shape of the landmass. We do know that if a river would have been in existence at this point of time, we know where the river would have been in motion. We know that the river would have been in motion in this downlying area. It would have maybe carried out a vertical erosion, further eroded that downlying area, further created a valley. And we do know that this particular portion would be not prone to getting eroded by the river because it is a hard rock on an elevation. So the river would never have managed to erode that. But let's suppose over a period of millions of years, there has been significant sedimentation which has happened due to wind, etc. And that sedimentation has created a thick layer of sedimentary rocks, for example. So let's suppose you have on top of this, so this is your basic formation of the earlier landmass. Okay, this is your basic formation of the earlier landmass, which is a hard igneous rock. And over a period of time, you have had a significant amount of deposition on top of it. So let's suppose that deposition has happened, and now you have sedimentary rock on top. But that sedimentary deposit has happened in a different manner. That sedimentary rock deposit has happened in a manner somewhat like this. Okay. Now, if I ask you for a river to flow, if let's say a river has to flow from here, the river will ideally choose this path or will it choose this path to flow? If I ask this as 1, if I name this as 2, which is the ideal place where the river is going to flow? Easy. 1, that is where the river is going to flow, isn't it? So, under this condition, under this condition, this is the topographical landmass, whereby this is your deposited soft rock structure. Deposited soft rock structure. That is sedimentary rock. This is your underlying hard rock structure. Underlying hard rock structure. Okay, that is your underlying hard rock structure. Now, if a river comes into existence after the this particular phase of the landmass, the river can come into existence, can originate at any point of time. So let's suppose the river was not in existence in the first image, the river came into existence after the second landform, or the landform has developed like this. So in this situation, if the river observes its motion and the river continues to flow like this, let's suppose the river is flowing here. It is having various different tributaries as well. Okay. and it is flowing like this. Now, this river which is flowing, it will carry out a kind of a vertical erosion. We can say that the river can carry out a vertical erosion, a vertical downward erosion can be carried out here, right? Now, if it will erode here in the downward direction, what do you observe is that it will get deeper, deeper, and furthermore, this entire portion will get further deeper. This entire portion, the depth will continue to increase because of the downward erosion by the river. The river will maintain its flow here, isn't it? It will carry out that further erosion. Maybe it will also erode this particular area of hard rock. If the downward erosion continues, this area of hard rock will also get eroded, isn't it? Now, this area of hard rock structure which gets eroded, ideally, if there would not have been any sedimentary rock above it, that area would never have experienced erosion, because ideally the river would have been eroding this particular portion. If it would have come into existence earlier, it would have eroded the downward portion of the hard rock. But now, because there is a superimposed structure of sedimentary rock, and the river has come into existence after that development of topography, and that river will erode even this portion of the hard rock, isn't it? So when you study the base rock, that is the igneous rock, when you study the base rock and you get a clue that it is the base rock which is getting eroded there, so that base rock, it is the erosion pattern is not indicating the slope characteristic of the base rock. Erosion pattern is indicating the slope characteristic of the sedimentary rock. So it appears to be superimposed. The river appears to be superimposed on the base rock structure, and hence it appears to defy the slope characteristic of the base rock. I will show you the better image as well. So here, if you will observe this, let's suppose this is the hard rock structure here. Okay, on top of it you have the sedimentary rocks which are created. These are your hard rocks, hard rocks. Here you have the soft sedimentary rock, sedimentary rocks. Now these soft sedimentary rocks, here after the deposition of sedimentary rocks has happened, then the river has come into existence. And as the river has come into existence, you will observe that there is a significant erosion of the sedimentary rock, and on top of that, even the hard rock, the crest of the hard rock or the anticline of the hard rock, which would never have been eroded, it would be the syncline which would have been eroded. But because the river has come into existence at a later point of time, even the anticline of the hard rock is getting eroded, and that creates what? It creates a kind of a superimposed structure. So that is the superimposed drainage. Now I bring you back to the definition. Now you will understand the definition of it. So here, when a river flowing over a softer rock stratum reaches the harder basal rocks but continues to follow the initial slope. Again, I will read it. When a river flowing over a softer rock stratum, means soft rock layer, for example, sedimentary rock, reaches the harder basal rocks, base rocks, that is the igneous rocks, but continues to follow the initial slope of the soft rock itself, it seems to have no relation with the hard rock bed. It appears to be independent of the hard rock bed. This type of drainage is called superimposed drainage. The stream has enough erosive power that it cuts through any kind of bedrock, maintaining its former drainage pattern. Now, if I ask you uh, the drawings, okay. So, first of all of you who are commenting on the drawings, I would take that as a positive. And it comes with the trade. Had I been a faculty of polity, maybe my drawing skills would not have been to this extent, but the subject of geography brings that. So the more you practice, you will be able to draw. Don't get disheartened. I'm not blessed by some external power. I've just practiced it enough. That is why it is there. You also practice it, so you will also reach there. Now, after that, now we come to the basic question. If I talk about the region where you can observe this superimposed drainage, will you be observing this superimposed drainage in a new landform or in a landform which is very old, which has undergone multiple different phases of erosion, deposition, etc.? So, where do you think you will experience superimposed drainage? In a newer landform or in an older landform? Very good. It will always be in a very old landform, right? Where over a period of time, now please don't get confused that newer landform, you just said that newly the sediments got deposited. That was an old landform on which the sediments have gotten deposited. So always you will find this in a very old landform where the landform has undergone multiple different phases of deposit, formation of sediment, sedimentary rocks getting created. So it is to be found in very old landforms, to be found in very old landforms. Okay. Now, if I ask you to apply the logic that we studied later last day and also today, in which part of India do you think that these kind of drainage pattern will be very prominent? If I give you the two options, Chota Nagpur Plateau, and if I give you the option alluvial plains, northern plains, where do you think this will be more prominent? Correct? In the Chota Nagpur Plateau, because it is an old landform. Alluvial plains, they are a very new landform which is created. So that is why you will find multiple examples in the Chota Nagpur drainage. Example, Chota Nagpur drainage. So in these old landforms, you will observe this superimposed. Example, Subarn Rekha. Subarn Rekha is the example of this. So in many parts, it will give you the appearance as if it is superimposed. So you have many of the smaller streams also indicating superimposed drainage thereby. Okay. Now, after this, we come to the pattern of drainage. So what do we mean by the pattern of drainage? So when the river flows anywhere, so the river basically observes a geometrical shape and pattern. So that is referred to as the drainage pattern. In simplest of the terms, the pattern exhibited by the drainage is drainage pattern. Which pattern? The geological pattern, the geometrical pattern indicated by the drainage, that is referred to as a drainage pattern here. So when we talk about the main types of drainage pattern overall, so you have various different types. Now, this is dependent upon the nature of the flow, nature of the flow of river, topography on which it is flowing, topography upon which it flows, erosional capacity of the river, erosional capacity of the river. So that is what the drainage pattern is basically going to be dependent upon. So here we will take a look at few of the important drainage patterns. Drainage pattern is relevant only for your prelims. Let me write it down here as well. Relevant only for your prelims. You can expect a multi-statement or match the following kind of question from here. So when we have the dendritic pattern. Dendritic, it represents a dendron. What is a dendron? Do we have any idea? Will we have antecedent in new landforms? If there is a new folding, yes. Yes, in the case of the nerve cells that you have, right? That is the dendron. So here, in areas where you have a uniform rock bed, where the erosion can be carried out uniformly anywhere and everywhere, that is where you will find that the river will be able to erode or find its path anywhere and everywhere. So here is observed in areas of uniform rock bed. That is where you observe them. In areas of uniform rock bed, that is where you will come across or you will observe them. That is what is referred to as the dendritic pattern. So there, the erosional capacity is uniform. So, okay, by the way, are we aware of the difference between the tributaries and the distributaries? Are we aware what is tributary and what is distributary? Good. Okay, no. Fair enough. It is not very complicated. So, whenever a river is flowing over a particular region, you will have various different streams which will end up joining the river, right? Various different streams will end up joining the river and add on to the water of the main river. Okay. So these are referred to as the tributaries. Whereas, as the river moves into the lower course, the flow reduces. Many of the times you will find that the there are streams which basically distribute the water, which diverge. Okay, these are your distributaries. This is the upper course, upper course. This is your lower course. So the distributaries, they will distribute the water away from the main river. Whereas when we talk about the tributaries, they add water to the main river. Okay. Now the image that you see on your screen, yes, for example, Hooghly is the distributary of river Ganga, right? Yamuna is a tributary of river Ganga. So here, when you take a look at this image is of a dendritic pattern exhibited by river Brahmaputra in its upper reaches in certain areas, where you will observe that the streams, they come from any direction, whichever it is possible. Okay, any direction, whichever it is possible, and then they join them. Now, again, if I ask you a logical question out of it, if I ask you, out of Peninsula Plateau and out of alluvial plains, that is the northern plains, in comparison to the Peninsula Plateau and the northern plains, where is it that you are more likely to observe dendritic pattern? Okay, it is going to be in the alluvial plains, because there the river have the freedom to move. There the river can chart out any of the course. Peninsula Plateau, many of the rocks, they are not of the same dimension. Many of the rocks, they have become metamorphic, they have remained igneous. In certain areas you have sedimentary, you have variation in rock structure in many of the areas. It is not that in Peninsula Plateau you won't find dendritic. In Peninsula Plateau also you have examples of dendritic, but more likely to be observed in the case of the alluvial plains, where the river can simply chart out their own path. Okay, now then we come across a very unique drainage pattern, which is referred to as the trellis drainage. Now, in the case of the trellis drainage pattern, you will observe something very unique. If this is the main stream here, You will observe, and these are your tributaries. These are your primary tributaries, and these are your primary tributaries. These are your secondary tributaries. These are your secondary tributaries. So here you will find that the primary tributaries, they are parallel to each other. Okay. So here the primary tributaries are parallel to each other. Whereas secondary tributaries secondary tributaries join the primary at right angles. They join the primary at the right angles. Now here, why is it that the primary tributaries are parallel to each other? How is it possible? Is it an act of God out there? No. It is created in those areas, it is observed in those areas where you have the intervening presence of the hard rock followed by a soft rock stratum. So the tributaries, they will be able to erode the soft rock, but the hard rock will be left behind. To elaborate upon the same, so let's suppose here, this is your primary tributary, these are your primary tributaries, this is your primary. The tributary joining the primary tributary is referred to as a secondary one. So here, let's suppose you have the condition where, let's suppose you have the presence of hard rock here, followed by a soft rock, followed by again a hard rock, followed by again a soft rock, followed by again a hard rock, followed by a soft rock. And this continues. Right. So in this region, if you have the landmass like this, you will observe that it is the soft rock structure which is being eroded by the landmass. All the tributaries will be able to erode here. So that is why the tributaries will indicate a kind of a parallelity. Now, how do you achieve this kind of a rock structure where you have an alternate placement of hard and soft rock structure? That is oftentimes attained by the process of folding. And the process of folding instigates this kind of an arrangement. Very good. How? So here, for example, let's suppose here, if you consider a landmass like this, let's suppose. Now here, let's suppose you have the presence of alternate arrangement of hard and soft rock. Hard and soft rock, followed by another hard rock. Now, if it gets folded, if there is a compression and it gets folded, okay, then what will happen? What do you experience this? So here, you will have a kind of a landform. Somewhat like this. You will have a kind of a landform. Somewhat like this. Where you have the presence of a hard rock, then the presence of a soft rock, then the presence of a hard rock. Okay, this is your hard rock, followed by soft rock, followed by hard rock. Let's suppose the folding has happened. Now, once the folding has happened, it will also get eroded, right? It will get weathered. Let's suppose the weathering and erosion has happened, and that weathering and erosion has removed this structure somewhat. in this manner. So what do you come across? After weathering and erosion has happened, you will come across these alternate arrangement of hard and soft rock, isn't it? You will come across a structure of hard rock here, in between soft rock, hard rock here, in between the soft rock structure. So that is where, due to the folding and then subsequent erosion, you come across a scenario where you have an alternate arrangement of hard rock, and then followed by a soft rock, and then followed by a hard rock after that. And that is something which continues. Okay. Now, that is your trellis drainage. Okay, all those who are still worrying about the primary and secondary, see, it is very simple by the name in itself. If you have a river like this, if you have a tributary which is joining this one, the main tributary, this is your primary. If let's suppose there is another small stream which is joining this is your primary, this is your secondary. Is that clear now? Is that clear? So that is the difference between the primary and the secondary. So the trellis drainage pattern develops where sedimentary rocks have been folded or tilted and then eroded to varying degrees depending upon their strength. Primary tributaries of the river flow parallel to each other and the secondary tributaries join them at right angle. Example you will observe in the Singhbhum region of the Chota Nagpur plateau, where there have been multiple different evolution of the various land masses that you come across. Then we have what is referred to as a radial drainage system. Radial drainage system is something you can associate with this particular image that you see, where around a central peak or a mountain system, you will observe that multiple drainages, they actually end up originating, but they move in very distinct directions. One drainage might move here, another drainage might move here, another drainage might move here. So once you have the drainages originating from the same region but moving in different direction, that is what is the radial drainage pattern. So that is where, if let's suppose you have a mountain system, now, across a mountain system, if a drainage originates and that drainage moves here in one direction, let's suppose another one moves in another direction. So that is your radial, because the point of origin is the same. So the streams, they radiate outwards from a central high point, generally volcanic peaks, the older extinct volcanic peaks, they are these sources. So good example is that of Amarkantak region, the Amarkantak plateau area, where from the same area you have the origin of two major systems. One is Narmada, one is Son. So from here you have Narmada and Son. While Narmada moves westwards, Son moves to the north and joins river Ganga. So that is basically the example that you will come across. Then you have the opposite of the radial drainage, that is centripetal. Opposite of radial is the centripetal. How is it the opposite? So in the radial, you had from one central point the streams originating moving in different direction. Centripetal is the opposite. That means from different mountainous areas, the water comes into the common central pool. And obviously, you cannot have very large rivers like Ganga or Brahmaputra or Godavari or Kaveri indicating that, because then the pool will be turned into, or a lake will be turned into a kind of an ocean. So generally observed in small mountainous streams, where you will have from different sides of the mountains, you have the streams which originate, they end up joining in or accumulating in the central lake, or a large lake, or a large pond of sorts, or a depression of sorts. So here observe that the river system is originating from various different heights here, right? And it is coming to the central depression. So generally observed for smaller mountain streams. Okay, can it be a delta? If you take the example of, let's say, a delta like an Okavango delta in Africa, then it can represent that centripetal, right? So Okavango delta, for example, in certain cases, even uh, if you consider the lake Eyre in the region of Australia, they also can indicate. So if you are talking about that, no, calderas won't be an example of this. No, calderas cannot be example. Okay. So the centripetal drainage, so streams in Ladakh, Tibet, and in the region of Nepal, you will have this. So the drainage flows here in centripetal, drainage flows in from all the various different directions into the central lake or depression. Okay. Now, then you have the pinnate drainage pattern. Pinnate indicates the veins of a leaf. So when you talk about a leaf, right? When you have a leaf, now in that leaf, how is it that the veins exist? The veins exist somewhat like this, isn't it? Now, these make a very small angle with the central vein, isn't it? So sometimes when you have a situation where from the surrounding ridges, the water moves into a kind of a valley like structure. So the streams, the tributaries won't be very long. They would be originating somewhere across these ridges, simply moving into the main river. So that is where they would be joining them at a smaller angle. Example, River Narmada. So here you will observe, here you have a hilly area. Here also you have, let's suppose, the hilly area. Right. So from the surrounding hilly regions, you have the water which drains into them. So it basically moves into the main river. It forms a very small angle. So that is the pinnate drainage. So it resembles the veins of a particular leaf-like structure. So that is the example of a pinnate drainage pattern. Now, if I ask you that can a river in its course indicate or exhibit different types of drainage pattern, will that be a correct statement or an incorrect statement? That in the course of a river, the river can experience multiple drainage patterns. Correct or incorrect? Correct? Because it will be moving through various different types of topography, right? Various different types of topographical features is where it would be moving through. So it would have multiple various different types of pattern indicated as well. Now, we come to the river systems of India. I'll give you the brief introduction and then we will end the session here. Now, here, for India, rivers are a lifeblood. Rivers are what gives rise to civilizations. River systems across the world, they are referred to as the cradle of civilizations. Be it the ancient Mesopotamian civilization, it emerged over the banks of river Euphrates and river Tigris. Be it the ancient Egyptian civilization, emerged across the banks of river Nile. Be it the Indus civilization or the Harappan civilization, emerged across the river banks. Rivers, they are a source of life. They are not simply water moving from one region to another. If we consider the rivers in India, they have significantly helped us economically. They have helped us in providing the required water at the domestic level for our animals, for our farmlands, and also they have helped significantly for the movement of men and material. For us, it is a matter of culture. For us, it is a matter of pride. That is why you will find in the various different temple architecture that you would have read in art and culture, rivers, they are accorded a very special and a unique place, even in the temples that we construct, right? Depending upon whether you talk about the various different types of temple architecture, you have a special place allocated to the rivers. The rise of many of the powerful cities have happened on the banks of river. The only reason that Patliputra emerged as the power center around 2000 years back, the modern day Patna, it emerged as a power center was because it lied at the banks of river, where it provided the facility for the people to have a unique form of defense, where in order to attack that city, you had to cross that very ever ranging river Ganga, which was almost impossible a task. But also, it provided with a unique facility that, if required, people and men and material can move in all different directions, north, south, east, west. Then, as late as, let's suppose, during the time of the Mughals, when Humayun was met with an adversity at the hands of Sher Shah Suri, suddenly the entirety of the royal household, including the royal members of the family, they exited the battlefield with the help of that river. That river has been a lifeline for all of us. So, for us, it is not a matter when we talk about a river, it is not a matter whether this river is helping us or not. It is a matter of reverence. As we will move ahead, we will see that wherever all these rivers originate, we end up worshipping those places. We have a shrine in those places, be it the Panch Prayags of Uttarakhand, be it the entire region of Mansarovar, which holds the origin of Indus, Ganga, or Indus, Satluj, and Brahmaputra, be it the Thal Kaveri, in where you have the origin of river Kaveri, be it the Trambakeshwar, where you have the origin of river Godavari, be it the region of Pushkar, where you have the origin of river Luni. We worship them, we revere them. They are a part of our life. So, here it is important for us to understand the various different rivers and their classification, and also the issues that we have created, due to which we observe these disasters and devastations, such as frequent floods, which in a way is a simple reflection of what we have caused or what we have done to these rivers. So, basically, in our own entirety of the country, you will observe that these particular rivers, there are various different methodologies by which you can classify the rivers. One of the methodologies can be, where is it that the water is drained? Is the water drained in Arabian Sea or Bay of Bengal? Now, if you classify the rivers on this category, then the rivers which drain into Arabian Sea will be river Indus, river Narmada, river Tapi, amongst the major ones. Now, these three, why is it that they drain into the river or into the Arabian Sea? Rest of them, they drain into Bay of Bengal? Because you have a water divide in the form of the Aravalis. The Aravalis, they ensure that the Ganga river system takes an eastward bend. Then you have the water divide in the form of the Sahyadris and the Western Ghats, isn't it? But here, can we classify Indus and Narmada in the same category? Indus, as mighty a river as it can get, Indus, which cuts through the Himalayas through a gorge, which is as deep as 5,000 meters from the closest mountain top. So, that Indus, can we club it with a peninsular river such as Tapi? No. So, that is not a perfect classification. So, that is why, in order to have an apt classification of the rivers, we go for the Himalayan drainage and we go for a peninsular system of drainage. Himalayan drainage are those rivers which originate from the region of the Himalayas and they move into Arabian Sea or Bay of Bengal. Now, all of these, they come from the mighty mountains. They will have a distinct speed. They will have vertical erosion, valley formation, gorge formation, and also large alluvial plains which get created. They will form very fertile deltas. They can meander along the way, they can shift their courses along the way. But when we talk about peninsular drainage, these are the rivers which are dependent on the occurrence of rainfall significantly, and that occurrence of concentrated rainfall in certain areas that provides the water. Now, this peninsular drainage, this is much older, much older than River Ganga or River Indus or River Brahmaputra out there. These rivers have been in existence for millions of years, much before the collision of the Indian plate happened. And these rivers have been moving through very hardened plateau structure of igneous rocks, where it is not possible for them to be meandering about, where it is impossible for them to be shifting their courses. So that is the classification that we have. So that is where we'll restrict the session here today. Tomorrow, we will talk about more about it. We will talk about the portion of the river systems, the flooding of the rivers, and we will be talking about the forests as well. So that is all from my side. We'll take a few questions here. Okay. Tomorrow, Chandrayaan 3, so holiday. Okay. Very nice and wishful thinking. Why couldn't we have a holiday for Luna 25 as well? So then the World Cup will also come. Then after that, some other event will come, right? So all the holiday that you want in your life, clear the examination, take all the holidays. Declare the holidays in your district once you get that post. Before that, don't take those many holidays. Okay. Muskan, don't just refer to the PPTs as of now and the ARMs. Will all the tributaries have their individual source of water? Absolutely, yes. And is it possible for a DM to declare a holiday under very unique circumstances? And you will have to give some significant amount of explanation, but you can. And what is the difference between drainage, radial drainage and centripetal? Radial drainage from a central point, it moves outwards in all direction. In centripetal, basically, it comes in from all directions into the central portion. Yuvraj, I went through your mail. Your question was about the article which appeared in the Hindu, and that is basically about the impact of El Nino cycles on the Indian monsoon, which is there, right? So there, that article talked about that how the peninsula part of the country is not very much impacted by the presence of the El Nino, because in general for the past few years what has been observed is that here the pressure difference has created the amount of rainfall. But then if you talk about the monsoonal trough or the monsoonal low pressure, now that monsoonal low pressure exists or extends like this or like this. Sometimes it comes like this as well. So here, the southern portion of the country is largely insulated by the movement of the monsoonal trough. That monsoonal trough, it is in this particular portion where there is a weakening or the strengthening. That is why the impact of the reduced amount of winds moving from mascarene high or increased amount of winds moving from mascarene high is felt for the monsoonal troughs movement in the northern and northwestern part of the country. That is why during the La Nina years and El Nino years, you have such a significant difference between them. Is that understood, Yuvraj? Am I? Is that something which made any sense? Please let me know. And Shubham, when should we choose optional subject? As early as possible. Once you have had a clue about the GS, so choose the optional. The year that you are appearing for the examination, the year prior to that, by the month of December, your portion of optional should be completed at least once. Does that source of tributaries is from underground? Not always. Not always. It can be from the melting of ice and snow as well. Okay. Uh, Pula, we are working on that, my dear friend. And Sarita, make it separately. Pavitra will discuss it on Friday. And yes, Charan, that is sufficient. Madam, just concentrate on the important topics and the important articles. that is relevant today, that is going to be relevant tomorrow. For example, the economic growth rate, that is not going to be relevant 3 months down the line. So only concentrate on those which are relevant. Catch the larger trend. How volcanic mountains have an origin of a river. So where the volcano is not active anymore, where there has been a volcano but not active anymore. Okay. And Sahyadris are basically Western Ghats in the region of Maharashtra. They are referred to as Sahyadris. Okay. Superimposed is basically that that kind of a drainage pattern where it is influenced only by the top structure, and the erosion carried out, it appears to be disjointed from the base rock, the hard base rock. That is superimposed. Okay. Difference between Deccan Plateau is a larger subset consisting of the Deccan Trap, the region of the Dandakaranya, the region of the Karnataka Plateau, everything. Okay. And till when the syllabus of geography will be completed? So we will have an extra session. We had missed one session last Monday. We will have an extra session on this Saturday. We will aim to complete it that itself. I want to have as much attention to the concepts regardless of the speed. I want you to understand it, because once you complete this subject, then it is not something that you do it on a daily basis. Okay. And that monsoon belt, is it only affected by Indian Ocean dipole, or the Indian Ocean dipole affect India as a whole? It impacts India as a whole, but the Indian Ocean dipole will channelize more winds towards that monsoonal trough, creating a substantial higher rainfall. And in UPSC, which portion covers more world geography or in Indian geography in certain areas, but physical geography is the concept around which you can drive your knowledge of Indian geography as well. There are a live class. As of now, we don't have the live sessions. We have live webinars for the optional subjects. In case of Peninsular Plateau, the source of water is underground. In certain areas, it appears to be coming from underground, but it is basically a significant amount of rainfall which has recharged the pool in the elevated areas, underwater pool in the elevated areas, that keeps on slowly and steadily percolating, creating that kind of a flow. Okay. Ashish, PPT and ARM should do. Sakshi, mostly it will be from 6:30. You will get a mail and we'll decide upon it, let you know. Okay. Right. So that is where we'll end the session here today, guys. You have the webinars as well. So we meet again tomorrow. Any query which is left unanswered, our SMEs are here. No, don't make notes after for the ARM. ARM themselves are notes. Don't make notes for ARMs. Okay. So Jayant, we have significant amount of ports in western region of India. What are you talking about? We have all the natural ports are there in the western portion. Okay. Um, Dwaipayan, try to have the online reading of the Hindu in that case. Chitranshu, it will create moisture in the air, can create localized rainfall. Source of Luni Satyapal is in the Aravalis near Pushkar and in the Ajmer district. That is where source of river Luni comes. So that is where we'll restrict the session here today, guys. The SMEs are here. They will give the response to your queries. In case the queries are still unresolved, please don't worry. Write a mail. You can contact me. You can contact us at IS Live as well, and we'll get back to you. So till we meet again tomorrow, take care of yourself, relax. Goodbye. Thank you, and have a good night.